Same car, same engine, same driver, 3 oils, 7,500 miles each. Lab-tested used oil analysis on every sample. The oil that protected the engine best wasn't the one most manuals recommended. Today, 0W-20, 5W-30, and 5W-40 head-to-head in a modern engine. One clear winner, and it's not the one most drivers expect. Why the manual isn't the full story. Most people say, follow the manual and stop overthinking it. Fair enough, up to a point. But your owner's manual isn't written to maximize engine life to 300,000 miles. It's written to satisfy EPA fuel economy targets and emissions compliance. That doesn't make it wrong, but it means recommendations are optimized for corporate compliance rather than individual longevity. And once you understand that distinction, the results of this test start making a lot more sense. To cut through the marketing, we ran all 3 oils through a modern, naturally aspirated 4-cylinder with direct injection. The kind of engine sitting in millions of American crossovers and sedans right now. Identical routes, same driving style, same intervals. Each oil ran 7,500 miles with continuous temperature logging and lab-grade used oil analysis. No shortcuts, no sponsored bias, just data. The physical trade-off. Before the numbers, understand the compromise every oil makes. 0W-20 is extremely thin at operating temperature to reduce friction and maximize fuel economy. 5W-30 sits in the middle as a durability sweet spot mechanics have trusted for decades. 5W-40 is the heavyweight built for high heat and shear stability under extreme load. Every oil sacrifices something to gain something else. Our goal was finding which sacrifice actually costs you the least inside the engine over real-world mileage and real-world driving conditions. Phase 1. 0W-20. The current manufacturer favorite, and the oil sitting in the majority of new cars sold in America right now. Cold starts were excellent. Internal friction was at its lowest. Fuel economy improved by nearly 1 mpg compared to the thicker options. On a corporate spreadsheet, that looks like a total win, and for the first few thousand miles, it felt like one too. But here's where things got interesting. Inside the actual engine, the data told a completely different story. Average oil temperature ran 8 to 12 degrees Fahrenheit hotter than the other oils. By the end of the interval, viscosity loss hit 13%. Lab analysis showed clearly elevated levels of iron and aluminum wear metals, the microscopic evidence that metal surfaces were grinding against each other more than they should. Internal inspection revealed early varnish formation in the valve train and a noticeably thinner residual oil film after shutdown. The hidden problem is its safety margin. 0W-20 works, but right at the edge of its capability. Heat, load, and shear break it down faster than most drivers realize. In real American driving, stop-and-go traffic, summer heat waves, mountain grades, towing even light loads, this oil thins out quietly. It won't destroy an engine overnight, but it shortens lifespan 1,000 miles at a time. The kind of damage you never see until the engine starts consuming oil or developing noise at 120,000 miles, and by then, the wear is permanent. Phase 2. 5W-30. Same engine, same driving cycle. And this surprised us. The difference was immediate and measurable from the first oil sample. Average oil temperatures dropped 6 to 9 degrees Fahrenheit. Viscosity loss stayed under 5%. And the number that matters most, wear metals dropped 35 to 40% compared to 0W-20. Cam lobes retained a much stronger oil film. Varnish was noticeably reduced across the entire valve train. When we talk to master technicians who've spent decades building and tearing down these engines, their off-the-record advice was almost identical. They don't chase thin oil for fuel economy, they chase thermal stability. One veteran tech put it this way: if you want an engine to last, you need oil that doesn't surrender its film strength the moment you hit a highway climb in July. Another said something that stuck with me. Fuel economy sells cars, but oil film strength is what keeps them running past 300,000 miles. That's the kind of insight you don't get from a spec sheet. 5W-30 consistently delivered better thermal control and a more balanced wear profile over time. It wasn't designed to win a fuel economy test for a regulatory agency. Its only job was to protect the metal, and it did that exceptionally well without the cold start penalties of much thicker oils. For the vast majority of drivers in the vast majority of climates, this oil hit the sweet spot. Phase 3, 5W-40. On paper, the ultimate protection. Highest shear resistance, designed for extreme heat stress. In our testing, oil temperatures dropped even further. Viscosity loss was almost non-existent, under 2% after the full 7,500-mile interval. Wear metals like iron and copper hit their absolute lowest point, especially under high RPM operation and sustained highway pulls. But this next result changed everything we assumed about thicker oil. Protection isn't just about film thickness, it's about flow. With 5W-40, we observed noticeably slower oil circulation during cold starts. Pumping resistance increased during short trip driving. Those 5-minute commutes across town where the oil never reaches full operating temperature. In those specific conditions, the extra thickness didn't add protection. It added drag and increased the risk of fuel dilution retention in the crankcase. Mechanics call this oil a specialist. Outstanding when the engine works hard and temperatures climb past 230 degrees Fahrenheit. But for a standard daily driver doing light commutes and short errands, it can actually work against you. The right tool for the right job, but not an all-around solution. The verdict. After identical use across all three viscosities, the comparison was impossible to argue with. 0W-20 delivered the best fuel economy but showed the highest wear and fastest breakdown. 5W-40 offered incredible heat stability but proved unnecessary and sometimes counterproductive for light-duty driving. 5W-30 maintained near-ideal temperatures, the lowest overall wear balance, and the best everyday protection. It didn't game the regulations. It focused entirely on protecting the hardware. The lab data pointed directly and consistently to the middle ground, and so did every experienced technician we spoke with. The quiet reality most owners never hear. Many engines currently specifying 0W-20 were originally validated and durability tested with 5W-30. The shift to thinner oils wasn't driven by a sudden evolution in engine needs. It was driven by the need to hit corporate average fuel economy targets. That's why the exact same engine, identical pistons, bearings, and tolerances, calls for 0W-20 in the US, but 5W-30 in Australia, Europe, or Southeast Asia. Same hardware, different regulatory masters. Once you see that, the idea of blindly following one oil recommendation without considering your actual driving conditions starts to feel incomplete. What to actually use? Stick with 0W-20 if you live in extreme cold. Prioritize every last fraction of MPG and change oil every 3,000 to 5,000 miles, not the extended intervals the manual suggests. Move to 5W-30 if you want maximum engine life, drive a mix of city and highway, and plan to keep the vehicle past 200,000 miles. This is the oil that balances protection and flow better than anything else for everyday driving. Reserve 5W-40 for towing, aggressive driving, or extreme summer heat above 100 degrees Fahrenheit, where the extra film strength is a mechanical necessity, not a preference. When we asked experienced technicians what they personally run, not what they recommend to customers, but what they put in their own cars, not one of them said 0W-20. Most use 5W-30 for daily drivers and 5W-40 for anything performance-oriented. The only exception was engines with variable valve timing systems so sensitive they absolutely required the thinner oil to function properly. 3 oils, 1 winner. And a reminder that the number on your oil cap was chosen for regulatory compliance, not necessarily for your engine's longest possible life. The real mistake isn't following the manual, it's never questioning whether the manual was written with your priorities in mind. Drop a comment. What are you running right now? And are you rethinking it after this? If this video helped you understand your engine better, subscribe for more. We've got a full lineup coming that covers everything from maintenance secrets to the smartest buys on the market. If you care about your car and your wallet, this channel was built for you.